Now let's check out capacitors in parallel. In this particular circuit here, we've got a 36-volt battery, a 4 microfarad capacitor, and 8 microfarad capacitor. So what we're going to do is we're going to add those up. Our equation for equivalent capacitance is really easy. We just take the capacitors in parallel and add them up to get 12 microfarads. So this is similar to resistors that are in series. So now that we've got that 12 microfarad total capacitance figured out, we can start to fill out our VIR chart. It's our total capacitance. So 4 and 8 gives us 12. So on this bottom row here, we're going to be able to use this 12 microfarad capacitor. I'm sorry, 12 microfarad capacitor in our calculation here in a second. And you'll see in our equivalent circuit, we've already put in our 12 microfarad capacitor. Now, remember, we've got our Q is equal to CV chart over here. Now that we've got all the capacitances and all the voltages, they'll give us our charges. So as we multiply them across, we get 144, 288, and 432. So remember that for capacitors in parallel, again, the total charge is equal to the sum of the charges on each capacitor. So those charges add up to 432, like I said earlier. And finally, just like with all capacitors, when we find out what the charge is on each capacitor, for example, here on the 4 microfarad capacitor, which represents that 4 microfarad capacitor, we've got 144 microcoulombs of charge on either side. This side will be positive because it's on the positive side of the battery. This side, those charges will be negative. And that's it.